Welcome to aminacademy.com. In Laplace transform, let us do Laplace transform of some basic functions. Let the function be f of t equal t power n. So we have to find the Laplace transform of t power n. By definition of Laplace transform is integral 0 to infinity e power minus st into f of t. Here f of t equal t power n dt, where here s is greater than 0 and n is a positive integer. Here now we can write this integral like this, 0 to infinity. First write t power n into e power minus st. Since t power n is easily integrable, here now easily integrable is the second function. Now here we have two parts multiplication is there, so we have to use integrating by parts. Here let first function u equal t power n, that b equal e power minus st. Now we can see integral of uv equal first function integral of second minus integral of differential of first into integral of the second. Regarding this, we'll continue this. Laplace transform of t power n equal, here the integral 0 to infinity, we'll write one more time t power n into e power minus st dt. Now integrate by parts. We'll do the first function, that is t power n into integral of second. Here e power minus st integral, first write e power minus st dt minus integral of differential of first, that d by dt of t power n into integral of the second minus st dt. Now put the limit 0 to infinity, here also 0 to infinity. Here the t power n integral e power minus st is e power minus st over minus s, with the limits of 0 to infinity, minus integral of 0 to infinity. Differential of t power n is n into t power n minus 1 into integral of e power minus st is e power minus st over minus s dt. Here t power n over minus s, let us put the limits of infinity and 0 here. Here t become infinity, which means e power minus s into infinity, which is equal e power minus infinity. If you go as a denominator, it becomes e power infinity. E power infinity is very large number, so it is in denominator, so it becomes 0. So this complete terms become 0 when you substitute infinity, that is 0. After that, let us substitute the value of 0 here. Here e power minus st, here t is here 0 means 0 power n is 0, and which is multiplied with 0 with any number becomes 0, so this part also becomes 0. Then here minus s and minus is there, so it becomes plus, and n take out, n over s, and integral 0 to infinity t power n minus 1 into e power minus st dt equal 0 minus 0 is 0 only. Then n over s integral, write e power minus st into t power minus 1 dt. Now look at this expression. It resembles the Laplace transform of some other function, that is, it is a Laplace transform of t power n minus 1. Since integral of e power minus st into t power n minus 1 is a Laplace transform of t power n minus 1. So we are getting here Laplace transform of t power n equal n over s into Laplace transform of t power n minus 1. Keep going recursive, means suppose here t power n Laplace transform of t power n when n equal to 5 means here it comes n over s Laplace transform of n minus 1. 5 minus 1 is 4. Like that it is recursive up to going 1. Means here keep going recursively. Keep going recursively. Like that, here Laplace transform of t power n equal n over s into Laplace transform of t power n minus 1, which is n over s into Laplace transform of t power n minus 1 is, like here, Laplace transform of t power n equal n over s into Laplace transform of n minus 1. Going recursively, we can get n over s into n minus 1 over s into Laplace transform of t power n minus 2. Further, continuing, n over s, n minus 1 over s already there. Now further recursively becomes n minus 2 over s into Laplace transform of t power n minus 3. Like keep on going, we get, like here we write here n into n minus 1 n minus 2 over s cube Laplace transform of t power n minus 3. Further it goes up to n minus 3, n minus 4, n minus 5 up to n minus n. That becomes n minus n means it becomes 0. T power 0 is 1. So we can get it like we are going up to continuation. We'll get here n into n minus 1, n minus 2, like that up to 1 we are going here s power n. Now it becomes Laplace transform of t power 0, that becomes 1. Now n into n minus 1, n minus 2 up to n 1, it becomes n factorial over s power n into Laplace transform of 1 is, we know that it is 1 over s, which gives n factorial over s power n into s equal to s power n plus 1. So we got the result. Laplace transform of t power n equal n factorial over s power n plus 1, where s is greater than 0. Now this is the final result of Laplace transform of t power n, which is equal n factorial over s power n plus 1. Now we will put some values of n. We get, like, suppose Laplace transform of t power 5 is nothing but 5 factorial over s n plus 1, that is s6. Like whatever the index n, we can write it and get the value of Laplace transform of those functions. We have done. Please subscribe our YouTube channel.